Good afternoon, ladies and gentlemen. Today's presentation is focused on water footprint, respectively on limitation of sustainability assessment. Water is crucial not only for ecosystems but also for human society, and we are using several tools for sustainability assessment. For example, several indices such draw indices, water scarcity indices. We calculate indicators such water intensity, water effectivity, etc., etc. And one of these tools is also water footprint. What is important? Important is that the correct application of any sustainability assessment tool is the basis for credible result. Water footprint is a part of environmental footprint family. Environmental footprint family contain, for example, carbon footprint, GHG footprint, ecological footprint. It's a group of tools which are used for the assessment of sustainability and show us environmental issues from different perspectives. Individual environmental footprint methodologies can be characterized by significant variation in used methods, potential applications, and also in the policy relevance. Currently exist two different approaches to water footprinting. The first is focused on the volume of water consumed during the life cycle of a product, process, or services or organization, and is so-called volumetric. The second is based on life cycle assessment principles and is focused on the impact of water use on different impact categories, and this approach is named impact-oriented. Both approaches share the same general framework, which consists of 4 steps. The first step is setting objective and scope of study. The second step is accounting of water use. In the third step, there is created sustainability or impact assessment. And the last step is interpretation of results. Our study is focused on the volumetric water footprint approach because there are several issues or uncertainties which are important from the sustainability assessment. So, component of water footprint. Volumetric water footprint is divided into 3 colors. Blue water footprint is represented by the volume of fresh water which is consumed from water resources, from rivers, from lakes, reservoirs, or from groundwater. Green water footprint represents the volume, typically precipitation, but it is the volume of water in the soil moisture. Typically, it is consumed by the agriculture commodities, respectively crops. Grey water footprint is defined as the volume of fresh water needed to dilute pollution discharged into receiving water body up to a level of environmental harmless concentration. It's qualitative indicator instead of blue and green water, which are quantitative indicators. Okay, now we are going to examples of issues in the sustainability assessment. And first example is focused on the crop production. Water footprint of crop production is defined as a potential crop evapotranspiration, which is divided between blue and green water footprint. Green water footprint is soil moisture, and blue water footprint is a volume which is supplied to crop by irrigation, typically. What's the problem in the sustainability assessment? First, crop cannot evaporate more water than is available in the soil. So we can say that the green water footprint cannot be unsustainable. But how is it defined, the sustainability assessment in the green water footprint? It is defined as a comparison of green water footprint with so-called available green water resources. Available green water resources are defined as total evapotranspiration from land minus evapotranspiration from land reserved for nature vegetation minus evapotranspiration from land that can be productive. What is it? It's not real value. It's a synthetic indicator. But the importance of green water footprint lies in the fact that absence of precipitation, respectively soil moisture, leads to the need of irrigation. You need consume blue water resources if you haven't available green water resources. And the second point is that the blue water resources are formed by a part of precipitation that doesn't evaporate from the area. If you consume these precipitations to crops, then you create an availability of blue water resources. Which limitation is connected to the blue water footprint sustainability assessment? Blue water footprint of crop production is calculated as a potential crop evapotranspiration minus effective precipitation. You get very often a positive value, but this value omits local conditions. For example, you haven't available water for irrigation, or you are unable to irrigate because lack of irrigation equipment on the field. Also, this value omits different irrigation practices. For example, some techniques are based on precise dosing, but some farmers use constant dosing. Also, each irrigation equipment has different water efficiency, and also, especially in the situation when the irrigation water is very expensive, then you use less water and you maximize profit, not maximize crop production. Next example is focused on the sustainability assessment of hydroelectricity. Blue water footprint of hydroelectricity is mainly calculated as water losses from reservoir. Unfortunately, there are described 3 different approaches to calculation of water losses from reservoirs. First approach contains only evaporation from free water level. The second approach calculates water losses as evaporation minus evapotranspiration before the reservoir was built. And the last approach calculates the blue water footprint as evaporation minus precipitation. Everybody feels that these 3 equations provide totally different results. I have to say that only first is correct. The first limitation is based on necessity to use the same approach to calculation of water footprint in the same sectors, in each systems. Because if you use different approaches to calculation of water consumption, respectively water footprint, then the results of individual systems are incomparable. The next limitation is connected to the purposes of reservoir. You calculate the total water footprint connected to the reservoir, but it must be reallocated between different purposes. There is no clear or standardized approach to allocation, and each author uses different allocation strategy, which is very sensitive or which importantly affect the total or final water footprint value for each purpose. And the next limitation is connected to the calculation of evaporation, because this calculation is very sensitive on data, respectively on the availability of data and also on the time interval which is used for calculation. Now we are going to the sustainability assessment of greywater footprint. You can see calculation of greywater footprint, and you can see that the greywater footprint is calculated as amount of pollution for pollutant I divided by the assimilation capacity of pollutant I, which is defined as a maximal concentration of pollutant I in the receiving body minus natural background of pollutant I in the receiving body. And the greywater footprint is determined for each pollutant separately, and the highest volume or highest value of greywater footprint is taken for the result. Very clear, very easy to calculate. But the principle of greywater footprint calculations use nature background value and doesn't include the real status of the recipient, which is very important for the sustainability assessment, especially if you are not solve the study focus on the whole watershed, but focus on the one system. The greywater footprint is very sensitive to value of assimilation capacity, which is based on the ambient water quality based on defined standards, but there is no procedure for determination of assimilation capacity. There is no standardized how it should be defined. The next potential limitation is based on the selection of pollutants which are involved in the study. And the last limitation is based on the situation when the global environmental standards, which are used for calculation of assimilation capacity, does not take into account local condition issues. The next example is greywater footprint of wastewater treatment plants. You can find several studies where was calculated so-called reduction of greywater footprint, which is greywater footprint before the wastewater treatment plan minus greywater footprint behind the wastewater treatment plan. Sometimes you can find situation when the greywater footprint before and behind TPS is determined by different pollutants, and in several cases this leads to greywater footprint The next exercise is focused on the greywater footprint sustainability assessment of the area, for example, of the watershed. The greywater footprint in the area is not equal to the sum of the greywater footprints of individual pollution sources. Standardly, you calculate greywater footprint for each subsystem, and summarizing these greywater footprints, you get greywater footprint of the whole system. In the area, you need to go not through the point sources, but through the pollutants, individual pollutants. Since each source of pollution can emit a different pollutant, and the calculation of the water footprint in the area must go by individual substances, therefore the calculation of water footprint, greywater footprint in the area, must be performed iteratively. If the area consists of individual river basins, then the assessed area must be divided into subbasins which are solved individually. The next limitation is based on exclusion of self-purification processes in the area. Typically, you calculate greywater footprint as a summarize of individual greywater footprints, but you neglect the self-purification, and in the close profile of the catchment, you get different value of greywater footprint, which is not confirmed by the real quality data in that profile. So we are before the end. I would like mention 4 main points from our work. There is important to thoroughly define objectives and scope of study. Data which are collected within the water footprint accounting make a relevant background for the sustainability assessment. The second, the choice of method of water footprint accounting, which equation is used for water calculations, which water body assimilation capacity is determined, etc., can significantly affect the results of sustainability assessment. Water availability and water needs, we can say water footprint, vary during the year and also during the locations. Therefore, the impacts of water use vary by location and also by the time. And the last point is that the money studies report the total value of the water footprint as a sum of the blue, green, and gray water footprint. However, they neglect that the water need for dilution, the discharged pollution, so-called gray water footprint, can be used as a source of blue water downstream in the catchment. Ladies and gentlemen, thank you for your attention.